Hello everyone and welcome to this course on modern application development. Okay, so now with all of that behind us, we are now going to look a little bit more into detail on HTML and its variants. Okay, what is HTML? Hypertext Markup Language. So HTML in some form, as not quite the form that we know it now, was first used by Tim Berners-Lee in the original web at CERN, right, the European Center for Nuclear Research, roughly in 1989. I believe that HTML was in development by him even before that. Now it's not that it came out of nowhere. HTML, the idea of markup languages already existed, and in fact there was something called the Standard Generalized Markup Language, SGML, right, which was meant as a way for creating other markup languages which were more sort of domain specific. Okay, now SGML has a number of very strict restrictions on the structure, on the syntax, the validity and so on. HTML on the other hand was meant primarily for browsers, and right from the beginning one of the I think conscious decisions taken over there, which has had a very interesting impacts further down the line, is that since it was meant for browser interpretation, the approach that the original inventors took was that, look, it has to be forgiving of mistakes, right, because after all a person typing an HTML document is entirely likely to leave out some tag here or there, right, and let's say if I try loading that into a browser and the only thing that I keep seeing are error messages, I'm not going to really use this. Okay. On the other hand, most of the time if I know that a person started, let's say, a title or something over here and then they jump to a new paragraph, I know that the title has ended before I started the new paragraph. So why not just let the browser be forgiving of these kind of mistakes and do a best effort interpretation. Okay, so HTML was a markup language along the lines of things like SGML, which already existed at that time. It had a few things that were very specific to how you would mark up something for display on a screen, right, and basically for annotating hypertext, so to say. And given the fact, the context in which it was being used, the fact that it was meant for some kind of interaction between different people, right, they decided that the browsers also need to be sort of as forgiving as possible and do a best effort to display what can be displayed, right. This is an example of an HTML document, right, sort of pretty much the simplest document that you can think of. This first line that you can see over here, I mean, this is a modern HTML document which looks very similar to what HTML would have looked like 30 years ago, right, it's pretty much the same. But the point is, this line over here, doc type HTML, nowadays is considered more or less a requirement. You pretty much standardize and say, look, if you don't have that, it's not really valid HTML. In previous days, there were different variants of this. It wouldn't quite be this doc type HTML, it would be some other, they had things called DTD, document type definitions and so on, which were trying to sort of stick with SGML but were neither here nor there. Now what we have is in some sense a simplified version. More important is the structure of the document itself, right. What it says is, look, this HTML pairs up with this /HTML at the bottom, right. Everything in between is your main document. Now within that document you have a body which starts here and ends with the /body. Okay, so what you can see is that every one of these so-called tags, right, has some name, in this case body, in this case HTML. And how is a tag specified? By putting these angle brackets, right, the less than and greater than signs around it. No spaces, nothing else around this, just the tag immediately surrounded by these two angle brackets. Now this body and /body is a structural element. It says that everything within this is the main body of the text. Within that I have h1 and /h1. h1 is a first level heading, okay, which means that it usually would be in larger font size, etc., but how you display it is up to you. Similarly, you have another structural element called a paragraph. Okay, so now you can see where HTML is going, right. It's basically trying to sort of take the overall text and add these tags around it. The main text that you have is just this, my first heading, my first paragraph. You could have just written these two lines and you are done. Everything else around here is markup. right, which is doing two things. One is it's telling other readers or even machines that look at this document how to interpret what is in different parts of it, and also it is specifying that there is semantic content, right, meaning to this. This is a heading, this is a paragraph, therefore display them appropriately. So we always have paired tags like this, right? H1 is always matched with a /H1. The angle brackets are used in order to indicate tags, and the closing tag, as you can see, right, the /H1 usually has a slash associated with it. Okay. Some of the tags are location specific. For example, the doc type tag only makes sense at the heading, at the pretty much the first line of the document, right? One other thing is that all of these things are usually case insensitive. You could use either capital H1 or small h1. You could even have capital H over here and small h over here, and the standard allows you to just mix and match. That's generally not considered good style simply because it makes it harder to read, but there's nothing preventing you from doing it. Can you nest these tags? Sure. So for example, if I do something like this, right, EM is used for emphasis. Okay, this is a logical tag because emphasis, actually speaking, does not really tell you how it is to be displayed. If I say emphasis, does it mean that I should make it blink, or should I make it like in a bright neon color, right? What is usually done is to put it in italics, right? Use an italic font. What about strong? Strong indicates that whatever comes over here should be somehow, it should stand out, right? Once again, what is usually used is to make it bold font, but people sometimes confuse it and think that just by indicating strong it means bold font. It does not. Strong just means that strong is a logical markup, whereas bold font is a physical markup. Okay, in this case, since usually strong stands for bold and EM stands for italic, what will happen is the actual text which is between these tags will get displayed something like this. Why like this? First it will apply the strong, which makes it bold, and then on top of that it will apply EM, which will make it italic, and the result will be both bold and italic. Now automatically you might also realize that this means that you can have invalid combinations of tags, right? Supposing I write it like this, I start with EM, say strong, then give the word to be written, close the EM tag, and then close the strong tag. There's actually a mismatch because this EM goes with this and the strong goes with this. They are not nested properly, right? Since strong was the innermost tag, it should also have been the first one to be closed before I went and closed the other one. In other words, as far as the document standard is concerned, the order in which you do these things does matter. Okay. Now, like I said, most browsers are quite forgiving. So if you do write markup like this, there's a good chance that it will go through. At some point it will indicate there was invalid HTML over here, but it will still try and understand what you wanted to do and display something which it thinks makes sense. Okay. What happens if you don't close one of the tags, right? You don't close the strong tag, you straight away go and close the EM tag. Is this valid? Technically no. Once again, what will the browser do? Most likely try and make a best effort and realize that since you have closed the outer tag, the inner one must also have been closed. What about outright typos or spelling mistakes that we have over here? Yes, I mean this will most likely result in something which even the browser doesn't know what to do with, because something like this, it doesn't even know whether it's a starting tag or an ending tag or what it corresponds to, right? It might indicate an error, but it's unlikely to display it on the main page. It will probably just not format this the way that you expect. So like I said, there's a difference between the presentation and the semantics. Both strong and B will result in exactly the same output. Which one is correct? Which one is better, right? It's not an easy question to answer. Which one is correct? Both may be correct. It's not very clear what you wanted to do. Did you just want something to be in bold font? If so, both of them are okay. But strong is actually telling you something more than that. It's trying to convey that to the reader that you want to emphasize this in some way. That's why you have put it in strong. Whereas B is simply saying, okay, put it in bold font. it's up to the reader to decide whether it's important or not. Okay, so B, in other words, is just doing presentation without worrying about the meaning, whereas over here you are concerned with meaning. So when you do use tags in order to indicate functionality, be aware of that. You should, as far as possible, try and use them in a context where the semantics, the meaning, makes sense. Ultimately, that is the more long lasting and the more important aspect of markup. Some rough timelines on the evolution of HTML, right? Like I said, the original SGML based HTML started from the late 80s, right? Basically around 1990 or so. The first sort of formal definition, once the popularity of the web started taking off, HTML2 was defined in 1995. HTML3 as well as 4 were actually defined in 1997, right? And then for quite a long time, it was pretty much just HTML4 that continued, except that after a while, people sort of started switching over to something called XHTML, right? Now, what is this XHTML? This was based on the thing that, there was SGML by its nature and the way that it was constructed, right, is actually a very strict set of specifications. Whereas XML is something called the extensible markup language. It was meant to sort of reduce a lot of the difficulties associated with the use of SGML, make it easier to define new types of tags, right, variations on tags, encapsulate different kinds of data, while at the same time being simpler to use than SGML, right? And this is something that you very often come across in computer science, right? I mean, the original definitions are done by people who have put in a lot of thought. So it's not that SGML was unnecessarily complicated for the sake of being complicated, right? It had all that structure because of all the mathematical underpinnings, how it should be parsed, how it should be interpreted, what kind of tree structure should it have, right? A lot of thought went into that process, and that is why the entire SGML definitions were made in a certain way. But that also did make them difficult to sort of modify and understand easily. XML sort of took several learnings over the years, right? It was like more than 10 years of SGML, HTML use that came into play, and XML sort of tried to relax many of those problems or make it a little bit easier to use and understand. Based on XML, right, once again XML has very specific kind of meanings and interpretations. XHTML said, okay, now we'll once again look at it in the context of the browser, right? What kind of problems can be forgiven, what kind cannot, what should be expected of the HTML, right? But at the same time bring the X factor into play and allow you to have slightly different representations of things. That remained for quite a while, right, almost till the mid 2010s. And finally, now what we have is the dominant form is what's called HTML5, right? This was sort of in development since around 2008 or so. It formally became a W3C recommendation in 2014, and nowadays is pretty much the standard everywhere, right? And part of the reason why HTML5 really took off was in between, right, before the rise of HTML5 but after HTML4 and so on, there were a lot of websites that used so-called flash animations, right? So flash was a technology from Adobe which allowed you to do dynamic animations on websites. Right? Those websites, they had some nice features, they looked quite cool, they also allowed you to do more fancy interactions than possible just with HTML, but it was not really standardized properly. You needed a separate plugin, it was not part of the document standard, right? So it ended up being sort of heavy and not standardized. It would work on Windows machines, not well on Linux. It wouldn't work on the same way on different variants of browsers on the same machine, right? HTML5 attempted to sort of say, okay, let's address those issues and bring in some standards for how things can be done. And since about 2014, it's pretty much the dominant standard seen on the web. So what it does is that it also introduced a couple of logical elements, right? Things like block elements. So you will come across this div, which is a very common element that you're going to see when you write HTML documents. It essentially means this is a block, something like a paragraph, right? You could have inline elements, right, which just are a span. So it basically spans across a few characters and say this is how this should be interpreted or displayed. Now you could again abuse this in the previous manner, right? I mean, what we said about the difference between bold and strong, and just say, okay, this span of text has this characteristic, right? This font size, this, and so on. Ideally you shouldn't, but it might happen. You could do something of that sort, right? It allows you to have fine-grained control over what happens where. But to a large extent, always what we are looking for when we have any kind of document like this is, how do we specify logical structure rather than exact presentation? One additional aspect as far as that is concerned was the introduction of elements like nav, so the navigation bar, the footer, and so on, right? Now these things are especially important in the context of accessible websites. What we mean by accessible is, let's say a person is visually impaired and cannot read everything that's on the screen, right? Is there still a way they can interact with this website? And there are screen readers, things that will take the text that is on the screen and read it out to you. Now if this text is just one big blob of text, it becomes very difficult for a screen reader to work properly. But if you have used nav tags and footers and the divs and spans properly, the screen reader can actually do a very good job of finding out which is the important part. Let's say you have one div which says main content, right? You can directly focus on that, or there is another div that says abstract. That can be read out first, right? The nav can straight away tell which is the next link, which is the upper link, right? Any related links and so on. So that's where the logical markup becomes more important. HTML5 also introduced some new tags like audio and video in order to interact with media. Basically you can directly embed an audio segment or a video, an MP3 or an MP4 file directly into a web page, and it will play automatically. So it defines how the browser should respond when it sees those tags and so on. Certain other tags which are mainly only for presentation, something like center. There used to be a tag called center which would explicitly allow you to center a certain thing on the page. But think about it, right? I mean, going by our original definitions, that's direct physical presentation. It's not logical markup. Similarly, there was a font tag which would allow you to change the font that was used in a part of the text. Once again, they said, look, take this out of the HTML standard. There are other ways by which we can do this, okay? So HTML, now that we have defined what an HTML document looks like, what the tags are and so on, it also defines something called a document object model, right? So like we said, this is a HTML document. I've left out the doc type in the beginning, but it has this HTML and /HTML. Within that it has two substructures. There is a heading and a body. Inside the header there is a title. Inside the body there is a first level heading and a link, okay? All of this essentially corresponds to a single HTML document. Now this is the document as we see it before it is actually displayed. The first thing that the browser needs to do is to parse this, that is to say, take out all of these tags and say the tags are actually telling me something about structure, about how the entire thing is to be interpreted. And that is where the document object model comes into the picture, right? What it says is each of these tags this entire structure can be interpreted as a tree like this. You have the top level document. Inside the document, your root element is this HTML, okay, which basically corresponds to everything which is inside the document. Inside HTML, I have head and I have body. I have an element head and I have another element body. Inside head, I have a title, and inside title, I have the text of the title. Similarly, inside body, I have a heading h1, and inside the h1, I have the text of that heading. I also have a link, that is a tag. It has an attribute, right? This is not part of the text, it's an attribute, it's an href, right? And it also has the actual link itself, this link text, which is available over here, okay? So this HTML, the first thing that the browser does when it sees it is to try and parse it or interpret it as a tree, structure like this. Why is this useful? Because ultimately you need to understand this document object model in the context of web apps, because you might have a way by which you can directly manipulate parts of the DOM, right? So there might be something where in a programmatic fashion you can go and directly change this h1 element which is inside body, or you could set the style corresponding to body h1 and say, okay, this is what this heading should get displayed as. So although it's not very important for us right at the beginning, understanding the DOM is important in terms of how we would modify the structure of a page or how it gets displayed. So it's a tree structure representing the logical layout of the document. What that means is the direct manipulation of this tree is now possible, right? Because computer scientists for a long time have a number of algorithms that operate on trees. It means that we know how to sort of move trees around, restructure, change the parent element of a given element, change the contents of one, go down a tree all the way and change all the elements inside it in a certain fashion. All of that can be done nicely using algorithms that are already known. Okay, so the moment you have this kind of a nice structure to the document, all those things get opened up. Now in addition to that, a number of APIs are also defined on the DOM, right, the document object model. One of them is the so-called canvas, which basically allows for drawing arbitrary things on the screen. There is an offline API which actually tells you that certain websites, right, you might have come across sites that say, okay, click here to install it as an app, right? What that means is that the HTML corresponding to that site gets stored on your local machine, and the next time you access it, it will run even if you are not connected to the internet, right? There are now APIs for web storage, which basically allow you to store certain information on your local machine, which means that it can become persistent. The next time that you go back to the site, it might still remember where you left off and be able to sort of work with that. There are sort of utility APIs like drag and drop, which basically allow you to drag a file from your operating system folders and drop it into a certain location, right? So in other words, it brings this whole drag and drop that people are already used to on the desktop into the web browser. Okay, so all of those are defined as APIs, application programming interfaces, which the browser sort of standardizes and says, okay, if you use these APIs, you'll be able to get this kind of functionality. Now in most of the cases, when we talk about manipulating the DOM, we use JavaScript, right? That's not something that we are going to be getting into in any level of detail now or in the near future, but it's something to keep in mind if you are interested in advanced development of these applications. And the other thing is basically styling, right? How do I also control the representation of different aspects of the DOM? That is where CSS comes into the picture. Okay, and what is CSS is something that we do need to understand in a little bit more detail.